Welcome to Robotics in Depth. Today I'm here with Dirk Thomas and we're going to talk about open source robotics. How did you get into robotics to start with?
Well, it was already during my studies at the university where we started to have robotic classes. You learn about robots and how they interact with the environment. And we started to have practical courses. And in contrast to normal computer science, software engineering, we just program and then you run the software and it works or it doesn't work. The hardware, so working really with a robot and trying it out and have it work once and fail again and debug, it was much more challenging and interesting. So that got my attention very early. And yeah, from first practical courses, it started, and then you do your first kind of thesis in that domain. You do more lectures about it. You start to spend much more time and much more your focus on robotics. And yeah, so I ended up doing my master's thesis with robotic-specific topic, and then continued with a PhD, also in the robotic domain.
Mm-hmm. And how did you then discover ROS and the open source robotics? And did you discover open source before robotics or at the same time? Or?
Well, as a software engineer, if you work a lot with various different kinds of software, then there's always the concept of open source projects. And you've used them usually very early on, and you try to find out about new projects. Are there alternatives which are probably free, which is also always an interesting concept when it's open source, that you don't have to pay for licenses. And you see, can a free software and open source software match the functionality of another one, which is probably costly? And if that's the case, then that's great. And if it doesn't work the way you want, you can even contribute. So you're not have to wait for a company to change something, to add a feature, to fix a problem, but you can actually contribute yourself. And that's being able to change their own fate, basically, is kind of essential for that.
Yeah, and you can also stand on the shoulders of giants. The feature you need might be some small tweak and reasonably easy to add. If it's open source. If it's closed source, that small feature that you desperately need might be impossible to get in because there's simply not enough customer that needs it for the big company to do it.
Exactly, and that's usually why open source software, from my experience, is often more flexible, because there are more variety of users and they have different needs, and the open source community usually tries to address more of them than a company with a fixed group of customers has, and probably also feasibly doesn't need to, because they cannot implement every feature everybody requests.
No, they have to look at the
financially that might not be valuable.
No. Then they might go out of business. But if it feels scary for somebody out there, they know about an open source software, or in this case also open source robotics, which of course is also software, and they feel intimidated by doing the change themselves. Isn't it so that there is a community around where you could actually pay somebody to develop this feature for you also?
Oh yeah, that always depends on the community. But even if you provide a change, for example, there's usually always other people reviewing your code. It doesn't get accepted immediately or without anybody looking. So you have this kind of review, which is also good for you as a developer or programmer, because you get feedback from other people. It can be trivial things, just style-wise. It's very difficult to read. Just change your code that way, and it gets more easy to read. It does the same thing, but it helps you develop your skills. And I think it's also a lot of reward if you see, my change got accepted. The next version will have that, and I did that. That's a really great feeling in the beginning. So it's a very rewarding process. Of course, with a lot of people interested in the project, it can always be discussions, which can also feel like effort sometimes. But on the other hand, it's discussion for a better step forward. So
yeah, it brings out the best in us, because I am, as an old programmer, knows that sometimes I didn't write perfect code. So it would have been very nice if I had somebody to review it and encourage me to write better code, especially, as you said, readability and testability and all these things that we plan to do some other day.
Exactly, that's usually due to effort, always later.
Yeah, and this happens within closed source companies, because there probably isn't the same awareness that this is going to be out there, everybody's going to see it. We've seen some high profile cases where people in usually very good companies have written some reasonably bad code.
Yeah.
Because it they probably knew that nobody would ever look there, thought that nobody would ever look there. And in an open source project, you can't do that by definition.
Other people would have probably spotted that and like made their comments on it.
Yeah.
And even if you don't intend to change it, it's sometimes really beneficial if you can just look at some software product's code and figure out how it does it. If you don't understand why it behaves a certain way, you think it's a problem, then you look at the code and you understand why it does it. And you can see it's actually not a problem. I'm just like, maybe I can use it a little bit different to make it work. So even without the intention to change it, it can be very valuable. Either for understanding it or just for reviewing. Did the people really did that right? Can I review what they implemented there? It's like a security related function. I want to know what's going on there. So it's just the transparency is like helps a lot.
Yeah.
And even for our project, we made the experience when we moved our code base to a more public location, which was open source before, but on a private server. It was people could get access, but not easily. It was GitHub nowadays. That's just trivial. You just look at GitHub and you can find most of the projects which are open source. We moved these repositories, and before even telling everybody, we already got contributions because people noticed and just saw things. It could be simple enhancements or fixes, and we got contributions before even telling the people that we moved it somewhere.
Which is cool. They really, they discovered it, so to speak.
And that gave us immediately like the right impression that, hey, that was the right move to do. Move it more into public space that people can actively like see our progress and contribute.
And this is very interesting. And can you give us an overview of the project as it stands today, and where do you think it needs improvements? Because it is quite young, right? ROS isn't a 20-year project. It's
7 years old. I mean, it started 7 years ago with the first release, which was developed at Willow Garage for the PR2 robot. And it was very tailored at that time for like serving that purpose. So, for example, it was used to like having a pretty computational strong computer, actually 2 computers on the robot. So it didn't have to deal with like resource constraints that much. And so the initial development was driven by that, but very soon after that one was released, other people found the project and heard about that and started using it, not only on the PR2 but on other robots, because they saw that the features it provided, like it nicely helps you to separate your complex robotic software into components, which then you can replace one component with an updated version or a modified version. It like helps you to structure the complex problems into smaller, less complex problems. And this like enforcement or this like move helped you to get your projects done faster or be more efficient. And so people found that useful and started using that one. And from that it evolved from being only used on the PR2, spreading to more and more. In the beginning, a lot of academia, which used it for research. Because you don't want to, if you do a research topic on, for example, localization, you do not want to deal with object detection. You think somebody should have solved that good enough. It doesn't have to be perfect, but it's good enough that I can work on a different topic. And that's a big advantage, which ROS enables you to reuse the components and have them nicely separate, and helps you structure your code nice and modular and hopefully reusable.
And if you want to, your component can then go out into this community and also strengthen the community, and other people can use your work.
Yeah, so ROS itself is like has a lot of meaning. The core part is basically the communication, which lets these components talk to each other and does the administrative things, I would say. And then you have the actual components where somebody implemented an object detection or a localization or a mapping algorithm. And those are like individual components, and you can put them, mix and match them together as you need them. And these are like the algorithmic, the capabilities somebody developed. And they are shared in the community, which is great. And you also have a lot of tooling where people once write a nice graphical user interface to visualize the map and where the robots think he is. And you can reuse that again for different algorithms, or you can see where the robot projects in his sensor view where objects are, where obstacles are. So, and beside that one, the fourth area is basically the whole community, that people use the software and they contribute back. Even if Open Source Robotic Foundation is doing a lot of development for ROS, we're mostly focused on maintaining the infrastructure and providing the core system, patching the communication levels, and some higher level components. But a lot of the value, like the algorithms, they are basically contributed by the community. And the latest release, for example, has 1,500 packages from which we as like OSRF only contribute a fraction, a very small fraction actually, which is a good thing because you want more people to be involved and have a more variety of packages solving different needs.
Yeah, and this is of course also the benefit of the open source model, that you grew so big because so many people can contribute. That wouldn't have been possible in a closed system if the product hadn't been very successful and the company grew very big. But the product would probably have been expensive then. So this is available for anyone. Anyone can use it, anyone can contribute.
Yeah, and usually it doesn't even have to be like extremely skilled contributions. Sometimes it can even be documentation, tutorials, which I would say not even a programmer has to do that. Like people working on the software, seeing that it lacks a certain instructions or something, can fill that hole and provide documentation and tutorials for that. And that is as valuable as like a normal code contribution.
Yeah, because it helps everyone understand how to use the product, and I've used that a lot in this project, Robotics in Depth, when both learning about gear, how to set up gear, and also how to edit videos. I might need to learn more about that, but learning from both how do I do it videos, I like those, where people present how they do it and why they like to do it that way, but also short little snippets. Here you find the setting for this and that. I can't see the timeline in my monitor. You go to this menu and it takes you 30 seconds to see a video and then you're done.
Exactly. Yeah, and in the beginning it was used a lot in the academia area, and there were like all engineers or scientists which like used the software, so it had like a way more rough edges than it has nowadays. But today it's like you have on the one hand the hobbyist which just want to use ROS because it already provides like reading the sensor data for a depth camera like the Kinect. And it can follow, like as a simple navigation rule, it can follow an obstacle which it moves in front of the Kinect, for example. So you can implement your own tiny robot which just has a camera and it follows someone, which is already a great experience because you can do that in a hobby project with very low amount of time. So that's the one end. And then you have the other extreme where people want to use ROS on the really commercial end, where they want to use ROS on a robot they want to sell as a product. And so that's a very widespread for ROS to like serve the needs, and that's something where I think in the future has to even improve to allow the ease of use for the one side, but also the really demanding features of the other side in a way that it's easy to use but very flexible to address all those needs to basically make everyone happy.
For the customer, it's really great to have ROS in whatever robot system you buy, because you're not depending on the customer, the supplier to provide support for that, because you can get that from other sources, and that makes you much more confident when you buy, for instance, from a small supplier.
Oh yeah, you have much better opportunity to like extend the system later if you want to customize it. In the future, I could even imagine that you can buy like components for a robot. If you want to build your own robot, that you can buy a component, and that component, like a camera for example, we're not yet there, but could be ROS certified in a way that you just plug it in and it sends ROS messages. You don't have to do any custom protocol to read the data or any manufacturer specific things. It will just have a ROS specified interface, and the camera just works out of the box, which makes it easy for you because you can just choose whichever camera fits your like requirements. If it has that interface, you know it will just work. It will reduce your effort significantly. And if you do that with all of the components, and then you can build your system much faster, and you can really spend on the time on doing whatever you want your system to do, like the real application specific logic you can spend on, and don't have to do driver communication and serial data handshakes, etc. It's like you just concentrate on what you want to do. So that would be the outlook where we want to be in the future.
How far away do you think we are there? Because I agree with you, this is an amazing goal and I want to get there yesterday. But is this a 5-year time plan or a 15-year time plan?
So I think technology-wise, we are currently on the way to provide the functionality that we can have these small embedded boards run the next generation of ROS, which uses a different communication system. And this communication system will allow us to like run a simple on a simple sensor with a small ARM processor usually to just send the data out and even be configurable, for example, for frame size or frame rate or resolution. And I think the technology demos will come up in the next few years that we can show that and show the advantages. And then it will be difficult to project how fast manufacturers will adopt that. I think smaller manufacturers might adopt it easier because for them it's an incentive to show my component works easy with ROS, so it's an incentive for people to buy that one. For the more established, bigger manufacturers, it usually takes some time because they have their standard and they are convinced they should keep that. So it might take some time until they also consider to provide that.
But as long as the sensor or the component from the smaller manufacturer is sufficient, you're not tying yourself into a huge purchase because these components are cheaper compared to the whole system. So you would be more inclined to buy from a smaller supplier because there's many of them and one of them are going to be okay. And you know that sooner or later the big manufacturers going to come in with their research and know-how to make super high quality components, although they will probably always be more expensive.
Sure, but I mean the sensors will still have like intrinsic value which might differ them from one vendor to another, where just the quality of the sensor data is better, or you can get higher refresh rate, higher resolution. There will always be an intrinsic value why you buy one over the other, not only by the price, but having the ability that they have the same kind of ROS interface, which makes it easy to swap them out, just makes it more comfortable for the end user.
Yeah, and you could also test your way up. You don't have to buy the expensive one. You can start with the cheap one and then go, oh, this is good enough, I'm sticking with this one.
Exactly, or you just buy both of them and you have an easy way to compare them because you don't have to do the integration work.
No,
you just plug them in and you can observe the difference, and you can write your own benchmark or use it in your application and see what works for you. It just lowers the barrier to like use different hardware components, hopefully significantly.
Yeah, and this is, I think that this is really cutting into the Gordian knot here of robotics, is that it is time consuming to develop and it's expensive to develop. That's why we see reasonably slow progress. I don't think we see slow progress in robotics. There's a lot of stuff going on, but we see proportionally slow progress. And that is because of these two factors that separates it from software development and from many other things, that it is complicated and therefore time consuming and also expensive. Because everything is made to measure, everything is made in small quantities, because there simply isn't the market out there. But if we can come to the standard component that you were talking about, more development will be done, so suppliers will make larger batches of things, which makes them cheaper, and also more development is being done, so there's going to be more for the end consumer to use in the form of robotics. So
and I think this is exactly why I like working on ROS, or on the lower part of ROS at OSRF, because we develop like the infrastructure, we develop like the new communication mechanisms for this next generation of ROS. And we do this because we think the current system would not scale to those use cases. It's very difficult to implement the current protocol on an embedded device because of technical reasons. We use XML, which is not easy to implement in a like really small memory footprint embedded system because it's a very bloated protocol or bloated markup. So we think the move to a new technology like DDS we use for ROS2, that will be enabling to do all these things, like having the device talk that natively, have the easy exchange. And what's so nice in this project is not working on one specific domain and getting a new feature working and give it to the world, but actually with this project enabling all the other fields in robotics to hopefully increase their speed, accelerate them like on a global scale, that not only one domain makes progress, but everybody can have his progress happen faster and actually boost the whole robotic domain with that.
Yeah, because if I make a small progress and everyone in the community makes the same small progress, together we've made huge progress.
Yeah, and I think with the version of ROS we currently have, we already see this kind of acceleration. Before, it was often the case that people reinvented things over and over again, and the progress was not that fast. But now with ROS, the reuse, like, which is very common in normal classic software engineering, like everybody reuses software. I mean, of course. In robotic, that was not common. And with this like modular approach that you really split the parts of your complex system, you can actually gain and actually apply reusability like it is done in software engineering for decades already.
Yeah, and we know that that's the way to go. If everyone had to start by writing their own operating system, very, very few programs would be written today.
And so that's a good thing. And if we can leverage that and like improve the core system in a way that we can even speed up that development in the future, I think everybody in the robotic domain will benefit from that.
Yeah. Could we look at some of the, you see a lot of what's going on where ROS is developing or who's using it for something cool. Could you give us your insight there? What's the coolest package that's been added, or what's the coolest use somebody's done with ROS that you've seen?
Oh, that's a very difficult question with a broad amount of software being developed for that. But what I find always interesting, if people approach us and mention to us that they use ROS in a domain where we have never expected it. So it can be, I mean, sure, if a robotic company comes and has a robotic arm and they say we use ROS, then we're happy, but that's like an expected domain, I would say. But there are other companies which approach us and mention, oh, we actually use ROS for that. We had like a farming company close by our office come over to talk to us, and they actually do scanning of lettuce on a field and use ROS to detect with vision algorithms to detect the lettuce plants, and then trigger fertilizer to spray certain plants to make them space out correctly. So they basically kill off the ones in between to have every salad
pruning,
piece
basically.
Enough space to grow. And they use ROS for that. And they had that even set up in like a multi-lane approach that they had like 6 or 8 lanes in parallel, and they ran like 8 ROS systems with like one master controlling all 6. And it was just impressive to see that they choose to use ROS. There was no arm manipulation, no motors. It was not like a classic robot, I would say. And that's just an interesting example for us to see whether people use that. And actually, even better, we could talk to them about the project. We could give them feedback, and at the end, we could help them with easy tweaks to even adjust the system to work better for them. So this kind of like conversation with the community is for us always interesting to see how it's being used, because then we have a better impression for what should we develop in the future if we know more use cases. From individual package point of view, there are so many really great packages out there.
1,500 of them. It's hard to sum up that in a few sentences.
And these are basically only the released ones. Probably there are so many unreleased ones, and potentially even more packages from parties which do not share that they use ROS, or they do it in a commercial background where it's proprietary, which is fine with our license. But so we cannot even like estimate how many ROS packages are out there and how many users we have, because we only see like the public side of who downloads our software and stuff. And that's already like hundreds of thousands of users, which is great. But there are like individual packages which I think are really awesome because they just enable so much. I think from the developer point of view, like the tool Arvis we have is like a visualization where you can interact with your robot. It's very flexible. It allows you to visualize your robot. You can plan motions in that view. You can see how the robot sees its environment, all its sensor data from the perspective of the robot, from an outside perspective. You can see the map, how the robot builds that one. And you can add even additional features specific to your robot into that tool. So it's very flexible to enhance it and extend it. And I think these kind of like tooling things, they are so valuable that I think they are one of the crucial packages available with ROS, because I don't have to care writing my own map visualization, it's already there. And if I want to annotate it with specific information, I can even do that with like a small enhancement to it. And I think, as mentioned before, these are actually the packages which provide the general functionality to boost the development of a lot of other things, because people can just leverage that, and it's already there.
Yeah, that's my clear opinion also, that we should leverage each other's work, if that's in an open source free environment, and that's of course also what we do in a commercial environment. I buy a tool and use it to provide service to someone. So where do you see ROS going from now on? You mentioned that you're going down with the version 2, you're going down into really small pieces of hardware. Where do you see other roads ahead for you?
Yeah, so ROS 2 should basically address a couple of shortcomings of the first version.
Of course.
Like working in a very small embedded system will allow us to integrate it with like really small sensors or motors, for example, which is a very good domain. The other one is if you have multiple robots and they interact with each other, then ROS 1 has issues communicating over lossy links like wireless. There are approaches out there which the community actually came up with after ROS was like initially released, and there are various different approaches to that, and they are good for certain use cases, but they are not yet the final solution. So they work for some cases, but for some others they are not that good yet. So we think we need to improve the core to work better in that scenario in general. If we can match all those use cases, time will tell, but we try to improve that use case in general. And another thing is that when people try to use ROS in a more like commercial environment where they want to run it on a product, then some of the assumptions ROS makes are just not really applying to that. So ROS has been used in academia, so if you start up your more complex robotic system and something doesn't work out of the box, you do the standard computer trick, you turn it off, turn it on again, it will work. That works in a research kind of environment to some degree, but for a product that's just not feasible. Yeah. And that's why a lot of companies use ROS for prototyping, because they can try out new functionality and build like a prototype fast. And then before they actually sell the product, they like kind of clean up, they throw parts of ROS out, sometimes even all of ROS out, and replace it with other things, because they are more reliable, they have more deterministic behavior, etc. So something which meets their like product requirements. And this is something where we think ROS 2 needs to like improve significantly by using a new communication protocol, and also having the higher level software being designed way more with deterministic behavior in mind, and giving you like foreseeable behavior, and that you can introspect the system. If the product robot like starts, it should be able, because it knows what software it's running, it should be able to look at the running system and determine, is everything running? Is everything running according to a spec? Do I get enough images? Do my motors actually do what I tell them? Like all those kinds of checks, there's like kind of really a verifiable system. That will be one of the goals where we want to push to, that people can, without worrying, run ROS 2 in their product and know it's really product quality and solid.
And this takes time, this takes effort, and I mean, we understand this wasn't in the first release. I talked to Melanie Weiss, and she said they had a time plan of a year to finish the PR2 and ROS. It slipped a bit, but if we can understand it did, because this is a huge project, and I think it's amazing that you all contribute to this, and I think you and I can together thank all the other people out there that also contribute to this, and I think it's amazing, all this work.
Oh, it's a huge effort over time. A lot of people have contributed to the project, and a lot of the people being there on the first day are not there anymore, and the team shifts. New people come in, some people like move on and do other things, and that's a good thing, because you also get like new ideas, etc. So it helps the project. And as you said, like timetable always like difficult, and sometimes it slips with a deadline. That's another good thing, I think, for the open source development. Sometimes it takes a long time to implement something and get it right. But usually the mindset of the open source community is we release a version 1.0 not on that fixed date, but we have a certain list of features we want to do, and we have a certain requirement on how solid it should be, how bug-free it should be. It will never be bug-free, but
Nothing
it should
ever
not
is.
have any serious issues. And this basically defines your release. So you don't ship it when the calendar says you should, because you might ship something which is not yet ready, but you really try to get it right. And if it takes a little bit longer, yeah, that's the part of the engineering. It's really complex, so it usually takes longer than you first anticipate. And even if we will release a first version of ROS 2, hopefully this summer, as planned, we'll see if that will slip. We can talk about this in the fall. But the interesting thing is that this will be the first foundation. There will not be a complete replacement for ROS 1. It will take a lot of time for people to look at the new system, see the value, and then start moving over parts of their system. And that will take years. And I'm pretty sure even in several years, we will still see a lot of users just using ROS 1 because it's sufficient for their needs. It works well for them. They have invested development time, and they are happy with the approach. But we think also that new users, which have certain requirements, will adopt ROS 2 very early because they see the benefits and try to leverage them and don't want to use ROS 1 at that point when they see the advantages they can get.
But if everyone is free to choose what's best for them, this is just perfect, right?
Exactly. It's of course a trade-off between resources, so we cannot have the same manpower supporting two systems. So there will always be a trade-off how much effort you can put in.
Eventually the first version will be left alone and you'll focus on the two.
Yeah, but even if you look at ROS 1 nowadays, when people ask what changes between one release and another, then it's always a very subjective answer, because from the core point, like communication protocol and the client libraries for C++ and Python, I would argue there are very small changes between the releases because the platform has stabilized over the years. There have been changes 2 years ago which were more significant, but nowadays it's a small refresh, some cosmetic changes, some bug fixing, of course, where bug fixes sometimes also get backported. But it's not a very rapidly changing core anymore, which doesn't mean between one version doesn't change anything, because from 1500 packages you can imagine that half of them might have significant new things. They might develop rapidly, they might completely change how they look, they might provide completely new features. So it's always difficult what changes. So I think we'll just see the gradual shift that more and more packages in ROS stabilizes and need less maintenance because they just became solid by then. And we shift development effort to ROS 2 to push it forward and add more features.
Because it needs more work.
And also need more attention for fixing things when they come up. And people who use ROS 1 can still keep using that one, even if their things change fast. So I think there will be this gradual change where resources get more and more shifted to ROS 2. But yeah, I mean, as long as for the foreseeable future, I would say those systems will coexist, and they will not only coexist, but they will also interoperate. So when you have a big robot like the PR2 with 150 processors running, you should be able to take some of them where you need the new functionality and move them over to ROS 2 and still let this hybrid system basically talk to each other. Part ROS 1, part ROS 2. That lets you as a maintainer or developer of such a robot gradually move over and not do it on one date for everything.
And also only move over the parts that actually need to be moved over.
Exactly.
I mean, if parts of ROS 1 is working okay and providing the service they need, there's no reason to move them. So
exactly. So if that suits your needs for the parts which work, then better don't touch it. And if you move it, it will certainly require effort.
So I'm really looking forward to the time where I can buy a sensor, a motor, a processor, and flesh out a robot in a few hours. And I hope to follow you along this path. And thank you very much for doing an interview.
Of course, you're welcome. Thank you. It was a pleasure.
Yeah, thank you. This episode is sponsored by Aptomica. Everything you need in modular robotics. Or robots up close. What's going on in robotics, online and on the road. If you like this interview, don't forget to subscribe, follow us on Twitter, and subscribe to our email newsletter on robotsinDepth.com. You can also support the show on Patreon.